Good morning, students. In this section, we are going to deal about a new topic named beats. When you heard this word itself, what is coming to the mind? Beats in the music, right? So, we are not talking about that kind of beat. This beat is a different phenomena in physics based on the superposition of wave. We told about the formation of the standing wave. When one wave will come in one direction and it will strike and the other wave will be reflected. The incident wave, that means the wave which is going forward and the wave which is coming backward, is superimposing, and as a result we are getting a pattern that we have described in the last two, 3 videos, and that is about standing wave. Now, beats happens when two waves of almost similar frequency. Almost similar means there is a slight difference in their frequency. For example, if one frequency is 50 hertz, the other frequency may be 53 hertz or 54 hertz. So, there is a slight change in the frequency. Such kind of waves, when they travel in the same direction, they will superimpose each other. As a result, a new pattern will be produced. This wave will have maxima at some places and minima at some other places. Maxima means high amplitude, minima means low amplitude. So, when two waves having slightly differing in the frequencies travel in the same direction, when they superimpose, at the region of superposition, you will be getting maxima and minima. That is called beats. I will show the figure. See, look at this figure. One wave is passing like this. Another wave which is having slightly differing in the frequency. To show that only, I have drawn 2 lines here. See, when I draw the first line, the crust and crust is there. But the point where I am drawing the second line, crust and trough is there. Understood? The point where I draw the second line, crust and trough is there. So, two dissimilar waves, slightly differing in their frequencies. When you look at once, you will see, you will think that both of them are exactly same, but both of them are not exactly same. There is a slight change in the frequency. Here also you can see it is coming at the bottom, coming down here, but at this end it is just going up. So, there is a slight difference in the frequencies. When they superimpose, you can see there is a variation in the sound. There is maxima at one point and minima at the other point. That means in this region you will be getting a high amplitude of sound, and this region low amplitude, and here again high amplitude, low amplitude, high amplitude, low amplitude, like that it will go. So, maxima, minima, maxima, minima, maxima, minima, like that it goes. Okay. So, one maxima and one minima, that is called one beat. So, here you can see, if you just look sharp, you can see here one crust and one crust is superimposing. When that kind of things are coming here in this region, crust and crust is superimposing. In that region only we are getting the maxima of sound, high amplitude sound. But when you look at this region, here you can see crust and trough is superimposing. Just closely observe this line, black line. You can see crust and trough is superimposing. That is why you are getting minima here. One maxima and one minima produces one beat. Okay. Now, beat is the phenomenon caused by two sound waves, of nearly same frequencies and amplitudes travel in the same direction. And examples, tuning musical instruments like piano, harmonium, etc. Before we start playing on these musical instruments, they are set against the standard frequency. If it is not set, a striking noise will keep on coming till it is set. That means, see, during a musical concert, we have to tune the violin, you have to tune the guitar and all. If it goes out of tune, it will produce the vibrations of sound. That means high amplitude, low amplitude, high amplitude, low amplitude. That means a knocking kind of sound will be formed, a striking kind of sound will be formed. Okay. So, if some vibration of sound is taking place, then the musical instruments are out of tune. So, we have to tune them so that no beats will be produced, no vibration sound. What I mean vibration sound by the sound is reaching high, then immediately comes low, then reaches high, then comes low. So, it will comes, you will hear it as a vibration of sound. So, that vibration has to go. So, that is how we tune. So, beats is the normal phenomena that we are using in musical instruments to tune the musical instruments. Now, what is meant by beat frequency? So, beat frequency can be defined as the difference in the frequencies of two waves. That means, if first wave is having a frequency 430, second wave is having a frequency 434. Subtract both, always subtract bigger minus smaller. So, 434 minus 430, 4 beats. So, beat frequency will be nu1 minus nu2. This is not V1, okay? This is nu1 minus nu2. This is nu beat. Nu beat is equal to nu1 minus nu2. So, 4 beats will be heard. You can also write that as omega 1 minus omega 2, because omega is 2 pi nu. So, if it is nu 1 minus nu 2, obviously it will be omega 1 minus omega 2 also. Now, beats cannot be heard if the beat frequency is greater than 10 hertz. I already told, if the beats are produced by a sound, we can hear it as vibration of sound. You cannot hear the beats if the beat frequency is greater than 10. That is due to persistence of hearing. If we hear a sound, the sensation of that sound will persist in our ear for 1/10th of a second. If another sound comes before that 1/10 seconds, both the sounds will merge together, you will hear that as single sound only. That is why if the beat frequency is greater than 10 hertz, you cannot hear the beats. So, you can write like this: for beats to be audible, the difference in the frequencies of two sound waves should not exceed 10. Now, the phenomena of beats can be used in finding the unknown frequency of the tuning fork, and then tuning the musical instruments, all those things. So, how to find the unknown frequency of the tuning fork, those things we will do in the numerical section. Okay. Now, we are going to the last topic, that is Doppler effect. Doppler effect is the phenomenon of motion related frequency change. I will give an example. Just imagine you are standing on a platform, railway platform in the railway station, and you are standing, train is approaching you and the train whistles. As the train approaches you, you will hear the frequency of the whistle keeps on increasing. I am not talking about the amplitude of the sound. Amplitude will of course increases when it comes. I am not talking about the amplitude, I am talking about the frequency of sound, the shrillness of the sound. Sound becomes shriller, that means frequency will increase. And as the train goes by you, passes by you, then the frequency of sound decreases. So actually it is only one whistle which is having only one frequency. But due to the motion of the train, due to the velocity of the train, as the train approaches you, you will hear the frequency of sound increases, and as the train goes away from you, you will feel that the frequency of sound decreases. This apparent change in the frequency of sound due to the relative motion of the source and the observer is called Doppler effect. The apparent frequency of sound due to the relative motion between the source and the observer, and also the medium, source, observer and the medium, is called Doppler effect. So that is what I have written. Here I have given the example for the truck. When the truck approaches near the house, the sound increases, and when it passes by the house, the sound decreases. Actually, what I mean by sound is the frequency of sound, not about the amplitude of sound. Okay. So here, when the sound is coming towards the observer, when the observer and the source comes nearer to each other, the waves get compressed. That is why the wavelength decreases and frequency increases. Similarly, when they are moving away from each other, the waves get dilated. That means rarefaction is taking place. So the frequency appear to decrease. So when the sources are moving towards each other, the frequency will increase. That is why I told you, I am standing, the train is approaching me, the frequency increases. And when the train is going away from me, then the frequency decreases. So there is one equation which you have to study. There is one equation which you have to study with the beats. You can write like this: apparent change in the frequency. Apparent change in frequency, that is written as nu dash. V minus VO, observer, minus V minus Vs into nu. This is the frequency. Nu dash is equal to V minus VO by V minus Vs into nu. And nu dash is the apparent frequency. And write what all these things represents. Nu is the frequency of sound. Nu dash is the apparent frequency. Write all those things. V is speed of sound. VO, speed of the observer. Vs, speed of the source. We always take the direction of the sound as positive. If the observer or source, if they are moving in the same direction of sound, then VO and VL will be taken as positive. But if either the observer or the source, anything, whatever is moving opposite to the direction of the sound, then that velocity is taken as negative. For example, if the observer is moving against the direction of the sound, if the observer is moving against the direction of sound, then VO should be taken as negative. Therefore, the equation can come as V minus VO, that will be V plus VO by V minus Vs into nu. So like that you can make changes in the equations. If the source is moving opposite to the direction of the sound, this becomes plus. Understood? So that is the general equation. So using this general equation, we can find the apparent change in the frequency. Okay, so that's all about this chapter. With this, our entire physics chapter and the entire textbook is coming to an end. So study well and prepare for the exams. All the best. Thank you.